All right, let's do this. Today, we're going to crack open the black box of one of the most talked about technologies out there, large language models.
So you've definitely heard of stuff like GPT, right? Maybe you've even played around with it. And the way it just writes, well, it can feel like actual magic, but it's not. So how does a machine really learn to write or to code? How does it think? Well, that's exactly the question we're going to unpack.
Okay, to get to that answer, we've got to start from the ground up. Because to really get what a large language model is, you first have to understand the really big idea it's built on top of. And that big idea, it's called a foundation model. Think of it like the parent category. The key thing here is that these models are trained on just enormous amounts of data that isn't labeled. So instead of us telling it, hey, this is a cat, this is a dog, it just figures out the patterns all by itself. And that's what makes them so incredibly adaptable.
So with that in mind, an LLM, a large language model, is just a type of foundation model that specializes. Its giant data set isn't pictures or sounds. It's text. We're talking books, articles, websites, you name it, even computer code. Basically, its entire universe is built from the written word.
Okay, so that covers the language model part of the name. But what about the large? It's such a simple word, but the scale we're talking about here is, honestly, it's pretty hard to wrap your head around. So let's try to put that big L into perspective.
Let's take GPT-3 as an example, one of the models you've probably heard of. It was trained on, get this, 45 terabytes of text data. I'm just going to say that again, 45 terabytes.
Now, to give you a sense of what that even means, a single gigabyte can hold something like 178 million words. A terabyte is 1,000 of those. So 45 terabytes? You're talking about a library of text so vast a human couldn't read it in 1,000 lifetimes. It's just a staggering amount of information.
But believe it or not, all that data is only half the story. The model itself, the brain, if you will, is also massive. GPT-3 has 175 billion parameters. So what on earth is a parameter? The easiest way to think about it is like an internal knob or a dial. Each one is a tiny value the model can adjust and tweak as it learns. Now, imagine having 175 billion of those knobs to turn. That gives it an absolutely incredible capacity to find complex patterns.
Okay, so we've got a massive model with billions of knobs and a massive library of text for it to learn from. But how does it actually learn? Let's pop the hood and take a look at the engine that makes this whole thing run.
It really comes down to three main things. You've got the data, that's the fuel. You've got the architecture, that's the engine. And then you have the training, which is the actual process of running the engine on all that fuel.
Let's zoom in on the engine and the process, because that's where the magic happens. The engine's architecture, it's called a transformer, has this incredible superpower. It understands context. It doesn't just look at a word by itself. It looks at every single word in relation to all the other words around it. And once it has all that context, its goal becomes surprisingly simple. All it has to do is predict the very next word. And here's how that plays out. In the beginning, the model is basically just guessing, right? It might see the words "the sky is" and spit out "bug." It has no idea. But then it checks its data, sees the right answer, and it says, oops, that was wrong. Then it adjusts a few of those 175 billion knobs and tries again. And it does this millions and millions of times until it finally learns that, yeah, blue is a much, much better prediction. So once this whole process is done, you have this incredibly smart generalist. It understands language really well, but then you can fine-tune it. You give it a much smaller, specialized data set to turn it into an expert at one specific thing. And that's how you get a model that's amazing at writing computer code, or one that's a super helpful customer service bot. Okay, so that's the theory behind it all. But where are you actually seeing this stuff in the real world? Let's talk about how this tech is showing up in our daily lives right now. Honestly, you're starting to see it everywhere. Think about customer service. Those smart chatbots that can actually understand what you're asking, that's them. Or content creation. They're helping to write articles, emails, and yeah, you guessed it, even scripts like this one. And for software developers, they're becoming amazing assistants, helping to write and check code, which just makes everything faster. And as cool as all that is, it's so important to remember this one thing. We're just at the absolute beginning. This is just the start. I mean, everything we see today, it's really just scratching the surface.
As these models get even better, even more efficient, they're going to open the door to all kinds of new ideas and applications that we probably haven't even thought of yet. And that really brings us to the final question, doesn't it? We've peeled back the curtain a little bit, we've looked at the engine inside. So now that you know a little more about how these things actually think, what's next? What's some problem out there that you think a technology like this will one day solve? It's definitely something to chew on. Thanks so much for joining me.